Okay, in our continuing effort to do the same problem over and over and over again, we're on to CO2, molar mass 44 grams per mole. We have 0.216 grams. We're going to go to moles, 0.216 grams of CO2. This is grams CO2. And we want our answer in moles of CO2. And in 1 mole of CO2, there are 44 grams. So 0.216 divided by 44, 4.90. How is that true? 0.21, oh, that can't be true. See, caught my own mistake. Instead of entering 0.216 divided by 44, aha, 0.005 moles of CO2. And then we need particles, so we're going to go 0.005 moles of CO2, moles CO2, and 2 atoms, molecules, 6.02 times 10 to the 23rd molecules, and 1 mole, let's see, times parentheses 6.02 times 10 to the 23rd, close parentheses, enter, 2.95 times 10 to the 21st molecules of CO2. Okay, so 2.95 times 10 to the 21st, and we had 0.004909 moles. Okay, last one, silicon. Molar mass of 28. We need to go from particles. I'm just going to shortcut it, say part. And we're trying to go to moles first, and then we can get grams. Moles, particles. Oh, sorry, off the page here. Particles, and all I know is that in 1 mole there are 6.02 times 10 to the 23rd particles. Always write your units first. I swear it's going to keep things straight for you. Okay, so we have parentheses 3.11 times 10 to the 22nd, close parentheses. Since it's on bottom, we're dividing by. Divided by, parentheses, 6.02 times 10 to the 23rd. That gives us 0.051 moles of silicon. And then we got to go from moles to grams. 0.051 moles of silicon. Moles of silicon, and we need to go to grams of silicon. And in 1 mole there are 28 grams of silicon times 28, 1.44. 1.44 grams. And there are 0.051 moles. Okay, first part done. Let's keep going. All right, grams of calcium to molecules. Well, again, I'm just going to turn this over. Grams to molecules, so 2-stepper. We got to go through moles. Everything goes through moles, so 2.7 grams of calcium chloride grams of calcium chloride molecules. It's 110.9. I've got the answer up here, by the way, the molar mass. So anytime you see that grams, you better start looking at a periodic table. What? Oh, wait a minute. I gotta get moles, not molecules. Moles first. Moles. CaCl2. So 2.7 divided by 110.9. So I have 0.024 moles CaCl2, and then we gotta use that answer to go from moles to molecules. And in 1 mole, there are 6.02 times 10 to the 23rd molecules. Times 6.02 to the 23rd molecules. And I get 1.465 times 10 to the 22nd molecules of CaCl2. 1.465 times 10 to the 22nd CaCl2. Moles to atoms. That's easy. Doesn't matter what we have moles of. Moles. 1 mole contains 6.02 times 10 to the 23rd. Oop, again, I'm slipping off the bottom of the page here. That's what I wrote. 2.61 moles, what I'm given. Units of given. Atoms. 2.61 times, parentheses, 6.02 times 10 to the 23rd, close parentheses. 1.57 times 10 to the 24th atoms. 1.57 times 10 to the 24th atoms of phosphorus. Okay, let's see, we got to keep the question and the page. And let's see, we can move this up just a little. All right, molecules to moles. Again, pretty easy. 2.59 times 10 to the 24th molecules. With an E. And then dimensional analysis. If this is molecules, this is molecules. And we're wanting to go from molecules to moles. And all I know is that 1 mole contains 6.02 times 10 to the 23rd molecules. So parentheses, 2.59 times 10 to the 25th, close parentheses, divided by, because it's on bottom, open parentheses, 6.02 times 10 to the 23rd, close parentheses, 43.02. 2 moles, 43.02 moles of carbon dioxide. Okay. I'm going to flip this around so that I can work closer to the top. Alright, atoms to moles. Pretty easy, what I'm given. Atoms, and we want to go to moles. The silicon. Okay, 1 mole contains 6.02 times 10 to the 23rd. So that is 2.4, clear. Let's try that with parentheses, 2.4 times 10 to the 24th. Close parentheses divided by open parentheses, 6.02 times 10 to the 23rd, close parentheses, 3.98 moles. Hopefully by now, with this much practice, you're getting the hang of this. It's just the same thing over and over again. What am I given? I'm given 2.50 moles. What do we want to go to? Grams. So moles, grams of sodium. So in 1 mole, I know that there are, and look at the periodic table, 23 grams of sodium. And so 2.5 times 23 equals 57.5 grams of sodium. Moles to grams. We have 5 moles of CO2. Oh, sorry, I started doing it up here. Let's not do that yet. Okay, we're going to move everything up, move this down. Still see the problem? Yep. Okay, 5 moles CO2, 1 mole CO2, and we're converting to grams CO2. And there are 44 grams, right? 32. Yeah, okay. 5 times 44 equals 220 grams of CO2. At least all these are one-steppers. All right, 350 grams to moles. 350 grams of K2SO4, grams K2SO4. We want to go to moles, and then 1 mole. How much K2SO4? Okay, so that's 2 potassiums at 39 apiece, plus 4 oxygens. And a sulfur. I get 174 grams. I'm not above making math errors though. 1.81 moles. 1 moles. Okay, grams to moles. We're just going to do it on the page. How about that? This one will be easy. 240 grams of magnesium. Grams of magnesium. Moles of magnesium. In 1 mole, there are 24.3 grams of magnesium. 240 divided by 24.3, 9.87 moles of magnesium. Okay, and that's the front. Let's go to the back. Here we're going to have some more 2-steppers. Try and do them smaller so that I can get everything on the page. We're going to begin part 3 here.